In addition to lenticulae, Europa's surface is crisscrossed by dark linear fractures known as linea. These fractures, which stretch for thousands of kilometers, are thought to result from tidal forces exerted by Jupiter and its other moons. The constant flexing and stretching of Europa's icy crust may generate enough heat to maintain a liquid ocean beneath the surface, providing a potential habitat for life. Recent observations by the Hubble Space Telescope have provided tantalizing evidence for the existence of water vapor plumes erupting from Europa's surface. If confirmed, these plumes could offer a direct means of sampling the moon's subsurface ocean, bypassing the need to drill through the thick ice. This discovery has sparked renewed interest in exploring Europa and has led to the development of new missions aimed at further investigating its potential for life. Among these missions, NASA's Europa Clipper stands out as a flagship effort to study Europa up close. Scheduled for launch in 2024, the Europa Clipper will perform dozens of flybys, getting as close as 16 miles to the moon's surface. Equipped with a suite of scientific instruments, including cameras, spectrometers, and radar, the spacecraft will map Europa's surface in unprecedented detail, searching for signs of subsurface activity and potential landing sites for future missions. In addition to NASA's Europa Clipper, the European Space Agency, ESA, is planning its own mission to explore Jupiter's icy moons. Known as JUICE, Jupiter Icy Moons Explorer, this mission will focus on studying Ganymede, Callisto, and Europa in detail. Scheduled for launch in 2023, JUICE will enter orbit around Ganymede, becoming the first spacecraft to study a moon other than Earth's. Both the Europa Clipper and JUICE missions hold the potential to revolutionize our understanding of Europa and its potential for life. By studying the moon's surface features, mapping its subsurface ocean, and analyzing its chemical composition, these missions will provide invaluable insights into Europa's habitability and the potential for life beyond Earth. Looking ahead, the exploration of Europa holds promise for answering some of the most profound questions about the origins of life in the universe. If life is found to exist beneath Europa's icy crust, it would have profound implications for our understanding of the prevalence of life in the cosmos. It would also raise new questions about the nature of life itself and its ability to thrive in extreme environments. As we await the arrival of the Europa Clipper and JUICE missions, excitement continues to build within the scientific community and among space enthusiasts worldwide. The prospect of exploring a world with the potential to harbor life is a thrilling one, and the discoveries that await us on Europa are sure to captivate the imagination for years to come. In conclusion, Europa stands as a beacon of exploration and discovery in our solar system. Its icy surface hides a world of hidden wonders, waiting to be explored and understood. With new missions on the horizon, we are on the brink of unlocking the secrets of Europa and unraveling the mysteries of its potential for life. The journey to Europa promises to be one of the most exciting chapters in the history of space exploration, and the discoveries that await us are sure to inspire wonder and awe for generations to come. The exploration of Europa represents a pivotal moment in our quest to understand the origins and potential for life beyond Earth. As one of Jupiter's Galilean moons, Europa has captured the imagination of scientists and the public alike since its discovery by Galileo Galilei in 1610. Its smooth, icy surface conceals a subsurface ocean that may contain more than twice the volume of water found on Earth. This hidden ocean, warmed by tidal forces generated by Jupiter's gravitational pull, presents a tantalizing environment for microbial life to thrive. Europa's surface features, including its intricate network of cracks, ridges, and icy plains, provide valuable clues about the moon's geology and internal dynamics. The dark, linear fractures known as linea are thought to result from the flexing and stretching of Europa's icy crust, driven by tidal forces exerted by Jupiter and its other moons. These fractures may act as conduits for material from the subsurface ocean to reach the surface, potentially carrying signs of life with them. In addition to linea, Europa's surface is dotted with enigmatic features known as lenticulae, or freckles. These features, ranging in size from a few kilometers to tens of kilometers across, are thought to form as warmer ice from below rises to the surface, creating domes, pits, and other distinctive shapes. The presence of lenticulae suggests that Europa's icy crust is dynamic and actively resurfacing, a process that may help sustain the Moon's subsurface ocean over geological timescales. Recent observations by the Hubble Space Telescope have provided compelling evidence for the existence of water vapor plumes erupting from Europa's surface. If confirmed, these plumes could offer a direct means of sampling the Moon's subsurface ocean, providing valuable insights into its composition and potential habitability. Future missions to Europa, such as NASA's Europa Clipper and the European Space Agency's JUICE mission, will be tasked with studying these plumes in greater detail and assessing their significance for astrobiology. The search for life on Europa is driven by the recognition that wherever there is liquid water on Earth, there is life. From the deep ocean vents of the Mariana Trench to the icy depths of Antarctica's subglacial lakes, life has proven remarkably adaptable to extreme environments. If life exists on Europa, it may resemble the microbial communities found in Earth's own oceans, thriving in the cold, dark depths beneath the ice. One of the key challenges in exploring Europa's subsurface ocean is accessing it without contaminating it with terrestrial organisms. Any spacecraft or lander sent to Europa must undergo rigorous sterilization procedures to ensure that it does not introduce earthly microbes into this pristine environment. This challenge underscores the importance of international collaboration and adherence to strict planetary protection protocols in the exploration of potentially habitable worlds. Looking ahead, the exploration of Europa holds the potential to revolutionize our understanding of the habitability of icy worlds in our solar system and beyond. By studying Europa's geology, chemistry, and astrobiology, scientists hope to unravel the mysteries of its hidden ocean and determine whether it could support life. The discoveries made on Europa will not only shed light on the origins of life in the universe, but also inform our search for life on other icy moons and exoplanets. In conclusion, Europa stands as a testament to the boundless potential of exploration and discovery in our solar system. Its icy surface hides a world of wonders, waiting to be explored and understood. As we embark on the journey to Europa, we are driven by a sense of wonder and curiosity about the mysteries that await us beneath its frozen crust. The exploration of Europa represents a bold step forward in our quest to understand the origins and evolution of life in the universe. And the discoveries that await us are sure to inspire awe and wonder for generations to come. Orbiting Jupiter, the largest planet in the solar system, are a total of 80 known moons, each fascinating in its own way. Arguably the most interesting of them all is one of the Galilean moons, the mysterious icy world named Europa. Crisscrossing Europa are vast cracks and discolored streaks that combine to create a complex yet beautiful world. Upon closer inspection, many more strange features can be seen, such as Europa's mysterious freckles. So, what are these freckles, and what is causing the chaotic fractures that weave across its frozen landscape? A total of 6 spacecraft have visited Europa up close, photographing the stunning moon as they passed by. However, most of what we know about it comes from several years of observations made by NASA's Galileo spacecraft. Galileo arrived at Jupiter in 1995 and successfully orbited the gas giant for almost 8 years, performing many close flybys of all of Jupiter's major moons, photographing them in all their glory. But it was the images and data collected about Europa that were the most tantalizing. In fact, the information was so intriguing that the mission was extended to make a total of 12 close flybys of the icy moon. Despite its fractured and discolored appearance, scientists discovered that it is the smoothest solid object in the solar system. Its surface is fairly young, probably only tens of millions of years old, rather than billions like most other moons. Somehow, the ice on Europa is being resurfaced and smoothed out faster than on many other worlds. The question of why that happens has not been definitively answered yet, but it probably has something to do with what's going on below Europa's mysterious surface. Take this image captured by the Galileo spacecraft, for example. Several strange spots or freckle-like features can clearly be seen scattered across its frozen landscape. These spots, called lenticula, vary in shape and appearance, suggesting warmer ice rising up through the colder outer crust of Europa, much like magma chambers in Earth's crust. This process could be similar to that of a lava lamp. For example, the smooth dark spots may have formed when the warmer rising ice erupted through the surface, while the jumbled-up rough lenticula could be formed from small cracked fragments of the crust embedded in dark ice from below, appearing like icebergs in a frozen sea. Recent studies have found that these mysterious features may sit above vast lakes of liquid water that are entirely encased within the icy outer shell of Europa. This cracked outer shell is estimated to be mostly water ice, frozen as hard as granite, and approximately 15 miles thick. But these lakes may not be the only bodies of water Europa is concealing, because below this thick icy shell, scientists have also found evidence of a vast subsurface global salty ocean. Europa's most striking feature is its dark crisscrossing linear fractures and ridges that stretch around the moon, called linea, which is Latin for lines. What caused these cracks is still a mystery, but they are likely weak points within its ice crust, which are being affected by Jupiter's gravity and the other Galilean moons. The icy moon gets stretched and released by the tug of Jupiter's powerful grasp in an endless cycle as Europa orbits the giant planet. This squeezing in and out is a process called tidal flexing, which may be causing these colossal fractures and ridges. The tidal flexing may also be creating enough heat inside Europa to maintain a liquid ocean beneath the moon's icy surface. The cracks aren't deep gaping voids but instead appear to be filled in with dark material, suggesting that some of them may have also been caused at least partly by the ocean below. Scientists found that the patterns of some of the longest line did not fit predicted patterns of fractures that should be created by tidal flexing as Europa orbits Jupiter. They determined that the patterns would fit very well. However, if Europa's surface could move independently and was not locked to the rest of the interior, as would be the case if a layer of liquid existed between the crust and the moon's rocky mantle, for example. Another piece of evidence for Europa's secret ocean is measurements that Galileo made during its multiple flybys. Galileo detected that Jupiter's powerful magnetic field was being disrupted in the space around Europa, strongly implying that a special type of magnetic field was being created deep within the icy moon. And scientists think the most likely cause of this mysterious magnetic signature is a global salty ocean. What's fascinating is that we may have already seen the water from this secret ocean escaping into space. Astronomers using the Hubble Space Telescope have imaged what could be water vapor plumes erupting off the surface of the icy moon. If this is water plumes, then it increases the possibility that future missions to Europa may be able to sample its ocean without having to drill through the hard ice. So, what are these mysterious freckle-like features found on Europa's surface? Well, there is strong evidence that below its frozen crust, large pockets of water exist, and along with even more evidence, those pockets may be sitting above a concealed global salty ocean that contains possibly 2 to 3 times as much water as all the water on Earth. What's really exciting about this potential discovery, however, is that scientists think that Europa's subsurface ocean could be the best place to look for life beyond Earth. Because of Jupiter and the other Galilean moons tugging on Europa, its seafloor could be heated by constant tidal flexing, driving hydrothermal activity similar to undersea volcanoes in Earth's ocean. For example, it is possible that with the correct ingredients for the chemistry of life under the ice of Europa, it could be habitable. With all this tantalizing evidence, Europa is one of the most exciting places in the solar system to explore. And we have 2 future missions to look forward to. The first is NASA's Europa Clipper spacecraft, which will perform dozens of close flybys, investigating whether the icy moon could have the right conditions suitable for life. The spacecraft will pass the moon as low as just 16 miles above the surface, soaring over different locations during each flyby. Estimated to launch in October 2024, we haven't got long to wait for this mission to get started. But we do have to wait a while until we start seeing the results, because Europa Clipper won't arrive at Jupiter until April 2030. The second mission we can look forward to is ESA's JUICE spacecraft, or Jupiter Icy Moon Explorer. JUICE is designed to observe Jupiter and 3 of its large moons, Ganymede, Callisto, and Europa. Incredibly, ESA plans to enter JUICE into an orbit around Ganymede towards the end of the mission, becoming the first spacecraft to orbit a moon other than the moon of Earth. The spacecraft will launch in April 2023 and arrive at Jupiter in July 2031. Both missions will bring brand new views of this mysterious moon and possibly confirm that it does have a global salty ocean beneath its ice that could support life as we know it. The early 2030s are going to be an exciting time for space exploration. Exploring the enigmatic moon Europa has long been a tantalizing prospect for scientists and space enthusiasts alike. Its icy surface, marked by intricate patterns of cracks and streaks, hints at a world of hidden wonders beneath. As our understanding of Europa deepens, so does our fascination with the possibilities it holds. Europa's surface features, including its mysterious freckles and dark linear fractures, provide valuable clues about its composition and history. The presence of these surface phenomena suggests dynamic processes at work beneath the moon's icy crust. Understanding these processes is key to unlocking the secrets of Europa's potential habitability. One of the most compelling pieces of evidence for subsurface activity on Europa is the presence of lenticulae, or freckles, scattered across its surface. These features, ranging from smooth domes to rough pits, are thought to form as warmer ice rises from below and interacts with the colder outer crust. The uniform size and shape of these lenticulae hint at a common origin, possibly tied to the movement of subsurface fluids.